Okay, awesome. Welcome everybody. My name is Dave Karow. I'm glad you're joining us today. The topic is, deliver results, not just releases, control, and observability in CD. And you might have seen the topic and thought, well, it should go one of several ways, but we'll clarify that pretty quickly. The first thing I want to remind you is that it's super useful if you'll rate this session. You can also use the app to ask questions, and my colleague over here will pass them to me. But for me, pretty important that you rate this. I'd like to speak at additional GOTO conferences. And if you find the talk useful, or if you have feedback about how it could be better, I definitely want to hear that. So yes, there's prizes for rating sessions or whatever, but for me personally, I'd super appreciate it if you take a minute when we're done and do the survey, and I'll remind you at the end. So this is how we're going to roll. I'll briefly just give you a little background on who I am and kind of how I got here. And then we'll talk about definitions. What do I mean by control and observability in continuous delivery? And then the role model section is who's already doing this and doing it well and transparent about it. Who actually tells people how they use these techniques to accomplish this. And you may be surprised at how long some of these companies have been doing this, even though this is kind of an emerging thing. Then we'll kind of wrap that up. I'll have 3 separate examples, but they'll wrap that up into takeaways, which you can take away with you to either sort of how do you apply this to your world, or if you're already doing some of this, what do you need to add in order to have kind of this whole thing happening? And then we'll have time for Q&A. So if you'd like a copy of the deck, just let me know. At this URL, I've put a really simple Google form. Just tell me that you want a copy of the deck, and I'll get it to you within a day or two, right? So I'll repeat this slide at the end as well, so you don't need to madly take notes. If it works for you to take notes, great. So split.io.results if you want a copy. So let's get started. So who am I? So my name's Dave Karow, and in the 80s, I was an undergrad at UC Santa Barbara, and the computer center never used all the cycles that their budget called for. So it cost this much money to run the computer center, and the administration used that much resource, and so there was always this extra that they wrote a blank check for at the end of the year. And they thought, well, why are we writing a blank check? Why don't we actually find a way to sop up some more of those resources? So they gave undergrads Unix accounts and taught us nroff and troff, so we could do our term papers using text formatting, using VI and nroff and troff. And if you know these tools, you know that they're not exactly a WYSIWYG editor, but it was fun, and it opened up a whole world to me, and I kind of became a Unix geek. I liked it. I had a lot of fun with it. So that's kind of how I got wrapped up in that. And then I ended up at Sun Microsystems at a time when the internal software distribution system was called SoftDist, and what we did was you had lots of different workstations, black and white workstations, color workstations, different versions of Solaris, different parts of the world. And somebody before me came up with a system where you could, instead of having a system admin configure every one of those servers to work right for the user, we had an on-the-fly system where a person would just type the name of the app they wanted to run, and we would on the fly determine what kind of workstation, what version, whatever, and there was a wrapper that would put them in the right code and execute the right thing, right? That comes back because it sort of reflects on what we're doing now, which is kind of a weird parallel. But so I got to use my tools there. Then I moved to a company and ran a developer forum at a place called GOTO Technologies, which is a database software company. Show of hands, anybody ever have a CompuServe account in the room? Okay. Great, all right. Those of us are dating ourselves. Awesome, thank you very much. So I was at GoGupta, and I ran a developer forum, and that was a fascinating experience because developers, back then there was no internet for the most part. There was some Usenet here and there, but there wasn't a place to go online. And so people came to our forum just as a place to hang out on the one hand. On the other hand, they used our tool to make their living, and so they were very generous with sharing tips with each other about how things work. So my job was to kind of play switchman and help people find the right information and share useful utilities or useful ways to solve problems. So another trend for what I enjoy about my career is the sort of connecting people with ideas that they're smarter than I am, but I know enough about what they're doing that I can hook the right people up, right? So I was then a product manager for developer tools. So we were doing developer tools, again, sort of in the relational database desktop space, and made a leap to synthetic monitoring. Now, synthetic monitoring, for those that know, is sort of outside-in programmatic robotic visiting of an app from outside your infrastructure on a schedule. And it was quite useful for a while because the internet used to be congested. So if you were in one part of the world versus another, there might be a huge amount of latency just related to how long it would take for you to get back to where the origin was. that problem has pretty much been fixed. And what happened was that synthetic monitoring required you to know everything the user was going to do ahead of time and build a script that went through the different steps and checked to make sure everything did what they're supposed to do and throw an alert if it didn't work. Show of hands, how many people think that the alerts after a new release were related to something being broken? Or were they related? I should ask that way. So the reality is that when somebody would push a new version of something, the alerts would all go off because the scripts no longer worked. Right? So kind of a pain to use that approach. What happened was somebody figured out that you could actually send telemetry back from every browser about how the user was doing, from every user everywhere in the world. And obviously you caught every journey all the time and had telemetry about that. Now you couldn't prove that a certain feature was available or not maybe unless you saw data points coming in for it, but RUM, real user monitoring, pretty much made this business just about obsolete. There's still a little of it done, but synthetic monitoring kind of mostly went the way of the dodo bird. I was also a product manager for load testing, and when I did load testing, what I was focused on was testing things when it was too late, which may sound kind of odd, but we were an outside-in verification service. So once you thought you were ready to go live for Black Friday or whatever your giant event was, we would beat it up from outside using our scripting that your developers or QA people probably hadn't thought about, and we'd try to find vulnerabilities. And it was useful, but the problem is that if you found a problem, you had very little time to fix it. So if your problem was a tuning of the gateway or a load balancer, you were loving it. If you had a problem in your architecture, you're basically doing whatever you can to try to get through, right? Then I had this complete shift, which was, so when I was doing that, we were a third party that came in after the fact and tested from outside your infrastructure when you thought you were finished. But the problem is that's no way to build code, because if you wait until the end to figure out it's broken, it's too late to fix it, right? So I ended up working at a firm called BlazeMeter, and the focus there was what we call shift left testing, which is just, I need to test earlier in the process so I can find the problems sooner. And there's some wizards that can write really fancy load tests, and they think they're very sophisticated, but a simple test run early is infinitely more valuable than a perfect test that's run too late. Right? And so that's what I spent the last 3 years doing, which was advocating to developers and testing teams and agile teams typically, how do I do performance testing? You don't have to go to a lab, you don't have to wait for an expert, you just need to figure out how to do at least some fundamental testing, kind of like unit testing for performance, right? So that's a lot about that. That leads me to where I am now, which is I'm an evangelist for this whole notion of progressive delivery with automated feedback loops. My title's going to change pretty soon because Evangelist is a little weird for some people. I walked into a Starbucks last week in Seattle, and I was ordering some tea for my wife, and I said, I'm an evangelist for Split. And the guy by the counter said, oh, have you heard of YWAM? And I said, I think I have. And he says, yeah, Youth with a Mission. I was in the mission field for 11 years. We should swap stories. I said, no, I'm a software evangelist, right? I'm right? And he said, and he paused for a second, they both laughed, and he paused for a second and said, well, it's not that different, which is probably the funniest thing that happened in the whole exchange, right? But, reach around your terminal and you're gonna love what happens. No, so anyway, I'm a developer advocate perhaps, but this is why I'm here, which is that what I'm gonna share with you today is actually not rocket science, and it's actually in a weird way not new. Most people aren't doing it, but so this quote, the future is already here, it's just not very evenly distributed. So there are several companies that have been using these techniques for over a decade, and some of them are very public about it. They actually write it up, they explain it, they give talks, they do videos, whatever. Some of them are less private, less public, so Amazon, which isn't in my talk, will tell you that experimentation is their competitive advantage, and that their ability to do it often and quickly is super important to them, but if you try to learn anything about how they do this, you won't. They basically, it's a closed book, right? But there's lots of open books, which is the great news, right? So I'm here to basically help spread it out a little bit more and spread it around. So remember, we're going to do definitions, then we're going to do kind of role models, and then we're going to do the takeaways. So now we're into the definitions. So what do I mean by continuous delivery, right? And there's two definitions. The one I'm going to show you here should look kind of textbooky. The ability to get changes of all types, including new features, config changes, bug fixes, experiments, into production, or just into the hands of users somehow, safely and quickly in a sustainable way. Now, Jez Humble, who wrote this quote, also has an alternative description, which is the Mojito test. Has anyone heard of the Mojito test? Okay, so the Mojito test is this. He says, your pipeline should be so good that you can hold a mojito in one hand and you can push a button in another that says, push the latest version of my code to production, and you should be able to relax and enjoy your mojito. right? Most of us don't work in an environment where we would say, yeah, whatever's the latest thing in source control, I'm just gonna, it's all gonna be good, right? It's Friday at 4 p.m., I'm out, right? Should take about 10 minutes to deploy, I'll be on the train, I'll have coverage at 6. Like whatever, like no one does that, right? So, but that's what he's saying, is that there should be less drama and more of this repeatability. So that's the goal. The goal is I should be able to push a lot of stuff more often with less lag time, and it shouldn't be a lot of drama, right? So when I say control and observability, what are we talking about? What do I mean by control and observability? So are we talking about control of the continuous delivery pipeline? This is sort of phases you might go through. You're building code and you're checking it in and you're unit tests and like, am I talking about this whole process? I'm not, right? So I'm not talking about how I run my pipeline. I'm not talking about how I orchestrate the code getting from one place to another, right? And for observability, has everyone heard of Hygeia? Anybody here from Capital One? Probably not. Okay, so Hygeia is actually a way to get visibility on how much time your code spends in different parts of the pipeline. So I didn't blow this slide up, but basically the first one is sort of commit time, build time, and then different test environments, and how much time your code spent before it got to production, and how long it's been in production since the last time you did a push, right? So I'm actually not talking about watching how code goes through the pipeline and understanding that, right? So if it's not about the pipeline, what are we going to talk about? Well, it's the payload, right? Like, why do you do all this? You turn the crank to get product or functionality or something out to your users. The pipeline is interesting and it's important, but that's not the thing people experience. So whether you call it code or config or change, it's the delivery. It's in the delivery that we show up for others. That's where people notice we are or aren't meeting their needs, right? So that's the thing we want to control, and that's the thing we want to observe. So the first thing we want to do is, so when I say control, I'll be more specific, control of exposure. And some ways people talk about this is, one notion is blast radius. So when you're pushing a new version of something out, it's nice if you could have a problem with only a very small percentage of your users, right? So Microsoft actually has this notion of concentric circles. And depending on the product, they might have as many as 20 or 30 different circles. If you've ever used a Microsoft product, in the updating, you can sort of choose, do I want to be in the very stable or in the early preview or whatever. You can choose what circle you want to belong in, right? So blast radius, the idea of limiting the blast radius is the idea of, if something goes wrong, that's actually not as bad as how much it hurts people. So if I only hurt a few users and I can recover quickly, it's not that big of a deal. But if I take my whole system down for 2 days, it's a big deal. So positively put, how do I control the propagation of goodness? How do I control who gets what when? And again, I might send out something to my friendly customers first to get their feedback, or I might have this early preview program which gives people an incentive to be sort of a beta tester or whatever. But I think this is the definition that's most important, which is, what's the surface area for learning? If I only give a feature to a very small number of people, I probably won't learn a lot about whether it's okay. If I give it to more people, I'm going to learn more. And if you've ever been into statistics, this is the notion of power, which is that the bigger the sample size, the more likely I'm going to get meaningful information out of it, right? So how do I have a dial for turning up and down how much exposure my new feature has to users in the field, right? So the really important thing is how do we decouple deployment from release? So deployment is physically putting something on a server, but that doesn't mean that users have to travel through it. And you may be familiar with Canary, which is where you have sort of 100 servers out there and you put new code on 2 of them and you start routing a little bit of your traffic through those 2 and see if those servers fall over or if the users abandon you in droves or whatever. That's a Canary test. That's a very chunky way to approach the same problem, which is I'm putting my entire release there and I'm sending some users through it. We're going to see a more fine-grained way to attack that problem. But how do I decouple deploy from release? And equally important, how do I make revert not equal to rollback? I don't want to have to push code somewhere to fix what I just broke. I just want to make it stop being broken. I want to turn off the part that's hurting people, right? And I want to do that instantaneously. I don't want to wait for code to get somewhere or servers to get booted that have the old version or whatever, right? I just want to basically have it happen instantly. So that's control of exposure. Examples of this, and the technology that we're going to talk about is feature flags, which is And I'll explain why we focus on that. So Canary is out there, but Canary will do a whole release at a time. Feature flag literally lets you say for one particular block of code, I want it on or off, or I'm giving it to people or I'm not. And you'll notice the first line in this example is 0% of your customers getting a feature. So if you're using a technology called trunk-based development, it's instead of having long-running feature branches, you're actually committing code all the time to master. So you only have really one version of the code, so you're not finding merged conflicts late. You're actually finding them before you go to lunch, right? And when you're doing that, you've got code in your master that you don't want to go live because it's not finished yet, right? You're working on it for 2 weeks or something and you're pushing every 3 days, whatever. So it's totally legit that you have a feature in there with it turned off. It's deployed to exactly 0% of your population. And then you might start ramping it up, and you might ramp it up first to testers or employees. We'll see how Facebook uses their employees to actually be a layer of safety. And then ramp it to 20 or 30 or 50 or whatever. So that's just progressive delivery or a gradual rollout. The other example is for experimentation, where you're taking some chunk of your population, you're deliberately having some people see one thing and some people see another. And I don't mean visually, it could be literally a different algorithm in the back end that's calculating recommendations. They might not know there's really a difference, you're doing something different for one cohort and another. And even though this says 50-50, you might not do this with literally half of all of your users. And you might say, I'm going to take East Coast users that are 18 to 35, and I'm going to split them in half and run an experiment within that group. Or you would choose where you want to run your experiment. And an example of an experiment would be you're trying to get people to create more tasks in your application. And so you're running this experiment, and you've got this great news, which is that 11.2% more tasks are being created by the people in the new version versus the old version, which would be like amazing news. It's a huge, huge change, right? But what happens if at the same time page load time goes up by 25%? So that's an unintended consequence. When you're doing experimentation, you want to be able to very easily figure out the thing you're trying to wiggle, and also we're going to talk about guardrail metrics, but how do I actually control how do I watch for other stuff we didn't intend, right? So that's the experimentation example. Now, for a lot of us are developers, right? So you want to see code. So this is super basic. I'm sorry for saying it's super basic because I don't mean to imply that you should understand this at first glance. What I mean is we've given a sort of a pseudocode example that doesn't have a lot going on here. And here, if you look, there's this treatment equals flags.getTreatment and related post. GetTreatment is saying, hey feature flag system, tell me, should the related post feature be on for this user or not? And if it's on, then I'm going to show the related posts. And if it's off, I'm going to skip that feature. So this is an example, just an on-off flag, like a light switch, right? But you might have a multivariable one, which is, I've got a legacy search algorithm in my app, and I want to try out 2 new algorithms and see how they differ from the legacy one. Maybe you've got one you built in-house and you're evaluating 2 commercial solutions or the other way around. And so you want to send users through one of 3 different experiences. And you say, hey, for this user, which search algorithm? And it comes back with V1, V2, or if it's not that, you show them the legacy. So, makes sense? This is the extent of the sort of, well, what's different about feature flags? The rest of it's your code. There's no framework here. There's no refactoring all your code. It's just, can you write a conditional statement, make a function call, and do something with the result, right? So observability. So we're switching gears. So I'm able to control who gets what and when, and do that dynamically, and do it whenever I want to do it, and do it in structured ways, whether it be randomly or whether it be by what attributes I know about the user. But then I want to know, who have I released this to so far? So there are a lot of people I talk to today have in-house feature flag systems where they have the ability to control who gets what. And it's mostly done to sort of gradually expose people and see whether things blow up or not. And then I ask them, well, how do you know if it's blowing up? Well, we look in the logs, or we have some metrics over here, or and those answers are typically related to an ad hoc process of trying to figure out how's it going, right? So when you build in observability, you know right away who has seen this feature and who hasn't, which, by the way, about half the people that have their own solution can tell you that, which is, I sort of keep a log of who hit the flag and what they got, right? But you also want to know how's it going for them and for us. So for them, did their behavior change? Did their experience change? Did they see app crashes? Did they get slower pages? Did they do more of what you wanted them to do? And then for us, are your response times degrading, like, the crashes thing is kind of about us. How's our server doing? How's our response times, our latencies and stuff, right? So that's what I mean by observability of exposure. Who's getting it and how's it going for them? So now we're shifting to the sort of the main body. This is the part where I'm saving you sort of hours of reading. Everything I'm presenting to you here, I'm going to share the links for in a tweet after our talk. So if you want to go deeper and kind of understand what's behind these conclusions. So who already does this and is generous enough to share? So the first one I would talk about is LinkedIn. You can probably guess from their acronym, they call this Excellent. And LinkedIn is pretty huge and pretty sophisticated, but they've been through quite a journey. And at the beginning, Exellent had the ability to target users, and these are their words, not mine, so they would split users between existing and new code. The challenge was that the impact analysis was strictly by hand. So they had data scientists here and there, and so if they wanted to do some analysis on how it was going, it was a 2-week process, and it involved begging favors. It wasn't somebody who was like waiting there, oh, you launched a feature, I'll get right on it, I'll have your analysis by tomorrow. It was literally like they'd beg a favor, and it took about 2 weeks to get all the data marshaled and come up with results. And as a general rule, nobody did it, right? Didn't happen much. So essentially what they had was feature flags without the automated feedback. But if you fast forward to today, Excellent does a controlled release with the built-in observability every 5 minutes. About 100 times a day they launch a different feature experiment and the ability to see what's happening right away and to keep statistics on whether it moved the needle or not for their users. And what's interesting is the bottom half of the screen says metrics you follow. So they've gotten to a level of sophistication where, let's say you're not the developer, you're not the product manager, but you're a stakeholder who cares about something. Let's say it's subscriptions for people subscribing for updates or whatever, right? And you want to know anytime anybody launches a feature which makes the number of subscriptions go up or go down. And so you say, I want to subscribe, I want to follow a metric for subscriptions for a newsletter, and you'd get a Slack alert or whatever, or an email, anytime anybody launches a feature which is moving the metrics for the thing you care about. So this is very sophisticated. This is, obviously, you notice this is a pretty looking screen. They've built this totally democratized. Anybody who can fog a mirror can use this UI to subscribe to metrics. And the developers who are using the experimentation feature have a very predictable path for creating an experiment and putting the stuff in the code. They don't reinvent the wheel, they just use it, right? So I mentioned guardrail metrics. So this gets its name from the rails along the roads where if you get a little sleepy or whatever and your car starts to go to the side, you go bang into something and something bad kind of happens, but you don't go off the cliff, right? So the idea with the guardrail metric is, again, we have that example where we had this great news. We're creating more tasks per user, but before we roll this from, say, 5% of our users to 100% of our users, we might want to be aware that we're slowing the page down by 25%, right? So great news, but on the other hand, maybe we ought to actually pay attention to performance because we probably didn't when we first built this feature before we ramp it. Before everybody says, your app's slower now. I'm thinking maybe I'll use a different app, right? So finding that early instead of as a result of 2 weeks of deployment and realizing that people are starting to defect in droves, right? So that's called a guardrail metric. And what a true guardrail metric is not something that the team that built the feature goes looking for or creates metrics for. The key to a guardrail metric is you as an organization decide that you're always going to pay attention to certain things that are really important to you. They could be subscriptions, they could be time on site, they could depend on your business. There's something that basically the large organization and the executives all agree are things we wouldn't want to break, right? We don't want to go off a cliff, right? And you watch those whether you want to or not. Right? So the team that's trying to fix something has what you might call a local optimization incentive. They're trying to make the tasks get better, and they're focused on that, as they should be. But if they optimize for that and crater the user experience, they're going to hurt the rest of the organization. And that's what guardrail metrics are about, which how do I actually build in the observability so that I can see unintended consequences? They can be good consequences, too. Could be that you've done something and it also increases customer sat, or more referrals, more shares of your service to somebody else. So this woman, Yazoo, was hired as just an individual data scientist at LinkedIn, ended up helping them retool how Excellent worked, and then runs data science. I think she has something over 100, maybe 200 people working for her now. And she spoke at a conference that Split helped put on in October of last year, and she basically netted it out and said, the key things are, You have to build for scale. When they started this, literally they would debate over email over what user IDs they could use in an experiment. So the way it worked originally is that they looked at the last couple digits of your user ID, and if you were between this and that, good news, you get experiments a lot. And if you had a different user ID, you'd never see the experiments. And they would then debate, well, I want this range for me, and doing that over email was obviously not scalable. They weren't going to get to 100 launches a day if they had to debate that stuff. So they built in the ability to create cohorts and make sure there weren't collisions and stuff into their system. And then they had an issue with trustworthiness. When they first created this, they literally would get results where on one day they'd say, great news, 50% improvement in the metric you cared about. And you come in the next day and you're about to tell your friends about how awesome it is, and it says, really sorry, but it looks like there's a 50% drop in the metrics you care about. Like from one day to the next, right? So how would you react if somebody told, if the system you were watching gave you signals like that, right? You wouldn't trust it, right? Like if it's flapping around, you would think, I don't know if this is really trustworthy. So they worked on how do we make sure that the statistics calculation is really rigorous and is repeatable and trustworthy, because otherwise it was like a fancy gizmo, but nobody really wanted to believe the outcome, right? And the last thing they did was, I showed you that screenshot of the subscription thing where anybody could subscribe to a metric, was to design for diverse teams rather than just data scientists. Because if you have a tool that only wizards can use, you end up naturally with a bottleneck, right? If only 5 people in your org know how to do this, or if only 1 person knows how to configure this, then you're always waiting. You're bottlenecking on that. But if everybody can understand this, pick it up and use it, then you'll get more adoption, and you're more likely to have it become something that's in use across your org, right? So those were the big takeaways from them. And I want to refocus on this. So why does balance, so right now we all live in a time where we're moving from giant siloed organizations with sort of I do this, I hand it off to you, you do this, hand it off to you, into more of an agile model, which is a smaller team that's self-contained. And the reason you want a smaller team that's self-contained is you don't wait for handoffs and you don't have a knowledge transfer problem. If you all know what you're working on and why you're working on it, and you've got the coders and the testers and the developers and the designers, all those people in one group, it's much easier to actually build without constraints, to actually build things quickly. So that's about decentralizing and giving local teams control, right? And then there's the issue of centralization, which can help you achieve consistency. It used to be, there's probably still our center of excellence in many of your companies. And part of the idea there was, how do I make sure I have some really smart people who sort of make sure we do this right? Well, what LinkedIn found was you actually have to have a centralized tool with a centralized algorithms and repeatability, and then equip people to run with it on their own. So you have to, on the one hand, you have to have, so this is the deal. So it increases the odds of achieving the results you can trust, and observations the teams will actually take seriously. If everybody knows that the system is trustworthy and we're all using the same version of truth, we all know how to decide if something's good or bad, then we're more likely to trust each other's outcomes instead of saying, well, you cooked the stats the way you wanted to cook them, I don't trust you, or whatever, right? So have a little taste of sorbet, cleanse your palate, or whatever. We're going to kind of shift gears, but you'll see some patterns. So now we're going to move Booking.com. Who here has heard of Booking.com? Okay, so Booking.com, for those of you who didn't raise your hand, ginormous reservation, booking service online. They actually have a bunch of different affiliate, other companies they own, but I believe they're headquartered in Amsterdam. And awesome for them, they're extremely transparent of what they do and how they do it. So I will explain at a high level what they do, and then we'll look at some specific quotes from them. So they treat every change as an experiment. You may have heard of an A/B test. Oh, I'm going to change the color of this button. I'm going to change this text. I'm going to do something different. But anytime they change anything and something that's going to affect the end user, they wrap it in an experiment and they watch the before and the after, or the on and the off, and they compare them. And we'll hear an interesting story, kind of a funny one about that at the end of this segment on Booking. They run 100 experiments on any given day. I mean, 1,000. So they're not launching, but there's literally 1,000 concurrently running all the time. So the scale of that's a little mind-boggling if you're sort of trying to keep track of that with spreadsheets or whatever, right? It's huge. And what's cool about them is that they have 2 sets of lenses. Most of the people in this space are focusing on what you would call statistical significance, and you're very disciplined about how many data records, how many sort of impressions you have to have before you can make a legitimate decision. And that might take days and days and days, or if your app is low volume, it may take longer than that. But what if you push a piece of code, you want to know whether it's burning, if it's breaking something, right? So they have the first layer they have, or lens they have, is a safety net, and they call it a circuit breaker. So if you push code and 50% of the impressions of that code throw errors, you don't really have to have a debate about whether you should roll it back, right? And they literally will do that often inside of a second. So if they push a feature and start exposing it to users and they're getting a lot of errors, they automatically revert in a second, and you can literally refresh your page and you're like, didn't I see? No, it's fine. Right? Literally, it's fixed that fast. So there was no escalation, there's no war room, there's no, we gotta get to the bottom of this. Literally, just the system automatically said, nope, something's wrong there, take another look, right? They also have controlled experiments, which run longer. And as I mentioned, they wrap everything in that. And we'll see how there's a surprising story about how they use that. So this is an article I'll give you the link for afterwards. You can also get it in the talk. But they wrote this article, moving facts, breaking things, and fixing them as quickly as possible. And online controlled experiments, not just to do experiments, but as a way of deploying code. So the first thing is they use, and I'm going to quote from the article, and this is roughly how it flows. So the first thing they do is they use it for asynchronous feature release, which is the thing I already described, which is I want to be able to decouple deploy from release. So I push the code out everywhere, and I only gradually expose it to my users, right? And they're giving a code example. Literally, if, I don't know what ET stands for them, it's their platform, track, experiment, and then the experiment name. If it's true, then run the new feature. If it's false, then run the old feature. Pretty basic, right? When they do this, they find that deploying has exactly zero impact on the user experience, because when they deploy, everything's turned off by default. So the act of physically deploying isn't when the drama has to happen. So the people who are doing the deployment are just moving bits around. They're not actually, oh my God, we better watch it. We better have a war room going. We better have everybody online, right? The goal is it's a non-event, right? They find that because of this, they deploy way more frequently and with less risk to the business. They can deploy over and over and over again. Deploying doesn't break things, releasing does, and they have a different way of controlling release. And the big win they get is agility. So the team is more eager to try things and roll things out. And when they do make a mistake, it's a very small mistake, and they recover from it literally, in most cases, inside of a second. It's just pretty good. Mean time to resolution. No stop at mean time to detect. You just sort of like, doot, doot, it's handled, right? But the thing about Booking is that they want each of the teams to be independent. So this circuit breaker I'm describing, and actually I'm kind of getting ahead of myself, so let's talk about the safety net, right? So irrespective of the sort of automatic thing, they use experimentation to make sure things are doing what they're supposed to and they're working as desired, right? So you wrap each feature in an experiment, and it lets them monitor and stop individual changes. And the normal way you do this, if it's not horribly wrong, is the team that built the feature is the team that watches the feature. It's kind of like carrying a pager if you wrote the code. Anybody work in an environment where developers are on call? Okay, so a fair number of you. Right, this is that idea, which is that who's more likely to know whether it's doing what we intended it to do? The people that wrote it or some other person, right? Not likely it's somebody whose job is just to watch for stuff that's wrong, even if they're a professional tester. Like the team that built it knows that what should change on the page is that should look like this instead of like that, or this flow should change, right? So they let the team that is releasing it monitor what's happening, and that team themselves can enable or disable it completely irrespective of who deployed the code, right? So the deployment, again, we decoupled it. So it's not, oh, tell the ops guys to revert. Tell the ops guys to revert. No. Guys, I don't like what we're seeing here. Let's back off and take another look at what we missed when we were testing this at a time, right? So that's the default way, which is they have an ethic, which is that the team that built it supports it and watches it. And they'll know they're the best ones equipped. And again, small teams know best why we built something and what we changed. So why would you expect some operations person or testing person or on-call person who's not part of that team to be able to figure out if it's broken or not and do the right thing if it is, right? Kind of intuitive. Like when you look at this, you're like, well, of course, that makes sense. Why would I do it any other way? So then there's the circuit breaker, which I kind of jumped ahead and told you about, which is that for the first 3 minutes of a feature release, it's on an automated, auto-reverting scheme, and it's actually less disciplined from a statistics perspective than the experiments. So they kind of cut some corners to be able to make the decisions faster, but they're cool with that because they're only looking for things that are glaringly wrong. They're not looking for a little difference in experience. They're saying, oh, if I'm getting tons of errors, or if people are basically, the typical user behavior just went, or like this, then I know that I should back off, right? So under any kind of severe degradation, they automatically abort the feature, which just means literally not turning off a switch in software and no redeploy. It just changes a signal to the system which stops doing what it was doing, right? And they call this out in their paper. They're like, this is a big divergence from the idea of decentralization, of having a team responsible for their own stuff. In this case, Big Brother kind of says, I know better. If 50% of the sessions are failing, I don't need to ask you whether you think it's okay or not. I'm just going to stop it, and then we can talk about it. So, but remember, I also said they use this for validating ideas, right? So they have a sort of a culture of measuring in a controlled way the impact changes have on user behavior. And it says user behavior, but it could be user experience too. Like they obviously care about latency, how fast a page comes up, but also what the user does. And their focus is actually rapidly on what the user does, not how smart their code is. And I'll show you an example of how that worked out for them in a minute. But so every change they do actually has to have an explicitly stated objective and hypothesis about how it should change things. Given that we know this, we are changing that because we expect this will happen. It's not exactly, grad studies level science. It's just, we believe we already know this, and because of that, we're changing that, and we think this is what's going to happen, right? And they have to explicitly state that somewhere. And then they measure, right? So their goal is to validate, did we get what we thought we were going to get? And the good news is if you didn't get what you get, the good news is you learn that quickly, as opposed to checking all these boxes and 6 months later saying, well, we did 49 things that were on the list of 100 things to do, but our metrics have barely moved at all. We need to lay people off. Or whatever, right? I don't know if you've been to that movie, right? But when you don't really know what affects what, it's very hard to maybe change how the system, how a user's experience happens. So I'll kind of wrap up in a second with Booking, but first I wanted to mention that they explicitly call out, they quote Eric Ries here, who says, instead of making complex plans that are based on a lot of assumptions, you can make constant adjustments with a steering wheel called the build, measure, learn loop. So you don't have to be a lean startup. You don't have to be a tiny company to think like somebody who can't afford to waste. And this is about learning faster, not just about deploying faster. And this quote here is actually directly from Booking, and this is actually even more to the point. So the quicker we manage to validate new ideas, the less time we waste on things that don't work. So anybody spend 6 months on something that went on the shelf after you were finished? I'll raise both hands. Okay, so how does that feel? Even if you're getting well paid and you had a lot of fun meals because you were working nights, it's actually not much fun to put stuff on the shelf, right? So less time wasted on things that don't work, and the more time left to work on things that do make a difference. So if I can kill something that's not going to work soon, I can try something else sooner, and I can actually experiments also help them to decide what they should ask, test, and build next. So given what we learned, remember their formula is, given what we saw here, we think that doing this will cause that to happen. So they're just constantly going through that loop. And the faster they can turn that loop, frankly, the more humane and the more sustainable their job is, because they're not just banging their head against the wall all the time. They're actually, oh, we did that. We tried this, it didn't work, but then we tried this, and that worked, right? So this is what I wanted to wrap up with. This guy, Lukas Premier, does a lot of talks. You can watch his videos. I'll send you if you follow me after the talk on my Twitter handle, I'll send you the URLs of his talk and his paper. But he was hired as a data scientist, I'm this really smart guy that's going to help them be better about what they do. And this is a landing page for Japanese hotels. And at Booking, they make money when people book hotels, for instance, right? And he looked at this page and he said, along the side there, each city only gets to list 5 hotels for the user. So what I'm going to do is I'm going to be smarter about how I choose those 5 hotels. I'm going to use all my data science chops, and I'm going to figure out how can I better predict which 5 hotels I should show so the user will book more hotels. And he spent 6 months trying this and trying that and trying the other thing, and the numbers didn't move at all, right? And then they said, wait a minute, maybe we're looking at this wrong. How do people interact with this page? And they looked, and this was something they could have found in the logs right from the beginning. Nobody clicks those links anyway. Ever, right? They only go to the search box and put in what they're looking for and search, right? So a colleague of his said, tell you what, let's do a one-line hack in the CSS and just make the hotels not appear. We're still using all your fancy data science in the back end, but just let's do an experiment where we turn them off and see if anything changes, right? And sure enough, nothing changed. Which has sort of made sense once they'd figured out that, in fact, the reason they turned off the CSS was because they realized nobody was clicking the link. So they wanted to confirm that. If I turn that off, does it change? Didn't change, right? So he's really kind of bummed about this thing. He spent first 6 months of his career. They didn't fire him. That was the good news. But he wanted to do something different. So he's like, I'm going to move on to a different problem. And the developer said, well, whoa, wait. You still have all that code in the back end that's calculating those very cleverly chosen hotels, right? So let's wrap an experiment around taking that dead code out. Let's take that, it's actually executing. Let's stop executing that code and pull it out. But we'll run an experiment around that to see if anything changes. So they pull the code out, and sure enough, conversions go up. The first time they saw any change in the metrics at all was when they gave up, ran an experiment around pulling out the back-end code. Why did pulling out the back-end code change what happened? Anyone want to guess? Boom, boom, boom. Speed, latency. Page came back faster. People got the one thing they wanted in the first place anyway, which was the search box. And they searched and they more often went on. Right? So the good news is it was actually a back-end change the user didn't even see, which changed the outcome, and the only reason they knew it changed the outcome was because they wrapped it in an experiment. So it's not always about making a button blue or green, right? This is literally an algorithm change in a way in the back that by making the page faster, improved the outcome they were seeking. So the fact that he tells this story, this is one of the things I like about DevOps in the space, is people are pretty open about their failings. They don't just like, well, I'm very amazing, and I want to tell you all the ways that I'm so amazing, and here's, I did this horrible thing. It took me 6 months to accomplish almost nothing. They didn't fire me, but I learned something, right? So it's an awesome story that Lukas shares here. It's in the video I'll share in the link. It actually goes through this. So the last example I want to cover, and then we'll kind of tie it together with the takeaways, right, is Facebook Gatekeeper. How many people have heard of Facebook Gatekeeper before? Right. Pretty much unless you thought you'd go looking for this, nobody had heard of it. I hadn't heard of this before, and I had researched, before I joined Split in January, I had researched this space, and I hadn't stumbled on that yet, right? But Facebook started at scale a long time ago, and they had a lot of problems to solve. And they were kind of a new organization, right? They didn't have a lot of legacy issues. They were kind of approaching things. We're a bunch of smart people. We're going to do this differently, right? And they realized that complexity was, in their mind, was a four-headed beast, which is why they created this graphic here, right? So states, it's very hard in a complex system to understand the states that it's in or it could get into. It's very hard to predict all that and even understand it, right? It's very hard to identify all the interdependencies. If you have 40 teams pushing code 3 times a day, it's really hard to understand the interdependencies between all that work, right? So they're like, nah, I don't think we're going to figure that out here. Uncertainty. The world is an uncertain place, and how your organization works when you're that big and decentralized is uncertain too. So they're like, that's kind of tough. But then they realize, wait a minute, irreversibility is something we can tackle, right? Think of it as an undo button, right? They're like, if I can make things to be, if I can tackle the irreversibility problem, I can basically, anything I do wrong, I can do an undo, and I can correct it. By the way, so anybody here have a kid that plays driving games on a PC? There's a game called Forza. My son will play this, and he'll drive along, and he'll crash the car into something, right? And then he just goes, he pushes the button, and it literally rewinds, and he gets to redrive that segment and not crash, right? It's not like restart the game. He literally can rewind exactly where he was coming around the turn, and he can then drive it again, right? So this is what they wanted to be able to do. They want to be able to kind of do an undo button and learn what they learned and then change something. So the first thing they do is mention that they don't try to coordinate their teams. There's all these teams working on stuff, and rather than have them all have to meet with each other or go to a change review board or share their stuff and make sure there's no conflicts, they said, we can't afford that. We don't have the time for that. It's too hard. So what they do is they use Facebook themselves internally very heavily. And they have out-of-band messaging that's not related to Facebook so they can talk to each other about it. And they push any change live inside the company for, I believe, for about an hour. And what they find there is that if you break somebody else's stuff, they will say, hey, you're breaking my thing. And they're able to stop it before it goes out to the users. So about an hour cycle, they can figure out whether to proceed or not. Then when they proceed, they go out to what most of us would consider a tiny population, which is they go out to 2% of their users. But if you're Facebook, 2% of your users is millions of people, right? And so they expose the feature to 2% of the users, and they watch. If it doesn't blow up, they start rolling it out. And we were in Seattle last week, and there was a DevOps engineer from Facebook, and we said, so how long between that 2% and 100%? Because the Microsoft guys had already explained, well, typically it's sort of 2 to 3 weeks depending on the feature, right? And she said, oh, about 3 or 4 hours. Because they have so many data points that they can actually know with relatively confidence that you know, if you've gotten to 50 million and then 500 million and 1 billion people and it hasn't fallen over yet, they're like, oh, well, let's give it to the other 1 billion people, right? You don't have to be that big to benefit from like the thought process, though, which is I do a staged rollout, I give it enough time that I can learn something before I go further, right? So then they have dynamic configuration, which is really what we already talked about, which is feature flags. How do I be able to turn off a feature in seconds and or be able to dial it up and down in a fine-grained way? And when they I thought this quote was good. We can dial features up and down in tiny increments, like only 0.1% of the people see the feature, to discover and avoid nonlinear effects. So when you have such a complex system, there's things you can't predict, right? And so how do I get the ability to actually tweak these things? And then the last thing is correlation. Their tools let them easily see the consequences of features even if they weren't looking for them, right? So that kind of wraps us up to the takeaways, which is the stuff that no matter what your scale, whether you want to be like Facebook or whether you'd rather never be like Facebook, what are the sort of key things? So remember, we talked about decoupling deployment for release. Boils down to this. Deploying is infrastructure. Pushing code out to servers is just plumbing, and it should be a non-event, right? Deployment isn't the thing that makes things break. Release is the thing that makes things break. And release is about exposing bits to users. So you decouple these two things, which means you can deploy all the time. And it's not the deploying that'll break things, it's the turning things on that aren't ready that will. So just so you can understand, most of these systems kind of have a similar flow. There's your app over here, and there's your system that controls it that's out of band. It's a separate system that's controlling what happens. And in your app, you make that call to the subsystem that understands whether a flag should be on or off, saying, is it on or off? And it does that on a user-by-user basis. And it knows how to do that because you create rules and you deploy those rules and cache them in the SDK that's in the app, right? And you keep them current. So now at this point, your app has the ability to make the decisions totally independent of anything else. It's autonomous. It says, is it a treatment be on or off for this person, gets back the response, and it moves on, right? Only thing you're doing from outside is being able to change those rules anytime you want without deploying new code, right? So one of the questions that comes up is, where do you put these controls? Is this JavaScript in my browser? Is this, in my database? Is this my app server? Where do I put this? And the answer is actually, you pretty much want to favor as far from the user as you can be, because you probably have more infrastructure, there, more power, more compute, and you can eliminate latency. But you pretty much want to make the decision as close to where the facts are. You would never send a piece of information back 2 hops in your infrastructure so you can make a decision back here. If the information's known here only, you put the decision here. Maybe you're calling a different endpoint based on that. You're not even going to go all the way back here before you decide, right? Whereas if you know who the user is when you call the app server in the middle, then put the flag there, right? So put the decision, favor the back, because while you can do a mobile app or a browser, the more stuff you expose in the front end. Has anybody heard of the Hong Kong woman who figured out feature flags and was toggling them to discover unlaunched features? So Facebook launched dating. She knew it before anybody else did, and she had a screenshot to prove it because she looked in Facebook and saw a feature flag that was turned off for this thing about dating. She tweaked the value, which caused her browser to show the feature, and she took a screenshot and put it on Twitter. And they weren't really stoked about that, but that's because they were using a flag in JavaScript in the browser, and she knew how to use browser debug tools to change the state of the flag, right? So one of the advantages of having the flags in the back would be that would not happen to you. But there's sometimes where you want a flag in the front. It's fine. So number 2 big takeaway, which is this is where people miss it, which is if people figure out how to do the flag, how to toggle a feature on and off, and look, I can configure it, I can even change it on the fly. Great. How do you watch what's happening, right? And usually people say, well, we don't really do that. right? So know what's rolling out, who's getting what and why. You should build in that. If you're going to build something, you should build that into what you're doing. And align the metrics to the control plane to learn faster. That may sound like, what does it mean? It's not a big deal. If I'm sending 5% of my users down a different experience, and I'm watching global metrics, how much does this have to be wrong or off for me to see it in the global metrics? Probably a lot. But if I'm watching it, if I'm watching the 5% instead of the 100%, then I'm going to pick up even subtle changes very quickly, right? So again, kind of an intuitive thing, which is if I align the metrics capture with the rollout, I can actually more quickly understand whether that rollout is bad or not, right? So an example of how that works is that we saw that we sort of asked the feature flagging system to make a decision. After the decision is made, we sort of dribble back an audit trail and we say, hey, by the way, for this user, they asked about, the system asked about this feature. I gave them this version because they passed this rule and it happened at this time. So I now know that Dave has been through this path and he was given the new thing or he's given the old thing, right? So I have a kind of a little bit of an audit trail there. Then I can ingest metrics. I can basically say, you know what do I know about Dave's experience or his behavior? So anything I know about Dave, whether it's something that I know right there in the code I was executing or somewhere else in my app, or I've got some external data source that knows what Dave is doing or what his experience is like, I can ingest that, and using that information, I can figure out how his journey is going, whether it's good or bad. And this is one of the promises I made in the abstract, which is what two pieces of data make it possible to attribute system and user behavior changes to any deployment. You might think, oh, this is all so complex, and how do I do all this correlation and what's happening? Actually, as long as you know what user ID you showed the feature to or didn't show the feature to, and when you did that, think about it. As long as you also have the who it was and a timestamp for an event, you can decide did the event happen before or after I showed them the flag. And if the event happened after I showed them the flag, there's a chance that it's related to that flag. And if I have that same stream for people that didn't see the flag, I can see what they did do or didn't do or what they experienced or not experienced. And I've got enough information to actually be able to say I've got these two cohorts. I've got the people that went this way and the people that went that way. And for the ones that went that way, I watched what they did afterwards, and they had way more app crashes than the guys that went this way, right? It becomes actually not such a hard problem to solve. Oh, yep, sorry. So going beyond MVP yields significant results. Build it for scale, solve for chaos. So we saw in the LinkedIn example, you actually want to figure out how do I make it so that a lot of people can work, but you don't have to worry about coordination. Make sure that it actually gives repeatable results. It should actually be trustworthy. And then design for diverse audiences. It shouldn't be a wizard's tool or something two developers know how to use. It should be something that everybody knows how to use. I missed your 5-minute warning. I apologize. Were there Q&As on the app?
There's a couple of questions here, but yeah, give a round of applause now.
Yeah. I apologize I went over. Thank you for your time.